Hello, ladies and gentlemen. It is I, Mr. White, and we didn't quite get as far as I wanted to in class today, so I thought that I would send you a quick little video to help you with your homework and to help prepare you for your test on Friday. So we're going to continue with some of the examples in this package. You can copy out these examples as I'm doing them so that you have them in your notes, and we'll go from there. So today we started off with investigating similar triangles. We came up with the idea that if two triangles are similar, then their corresponding sides have a common ratio and their corresponding angles are all equal. We worked through example number 1. It was kind of messy when we did it here. We worked through it here and it became neater. Then we started on similar triangles and we restated what we had learned. We worked through our first example. We looked at our second example and we noticed that we had to prove that the triangles were similar first. And what I'd like to do now is to move on to example 3 and example 4. And you copy these down and you can use them in your work. So, example 3. In the diagram, DE is going to be parallel to AC. So, DE is going to be parallel to AC, and they want us to find the length of AC. AC is here, so just for convenience I'm going to call it X for now. We could have called it AC, but I'm just going to call it X so that we know that that's the unknown. Now when I look at this, I see two triangles. I see a triangle ABC, and I see another triangle DBE. I also know that I have parallel lines, which you remember from grade 9 means that this angle will be equal to this angle. It also means that this angle here will be equal to this angle. What I have now are two angles inside two different triangles that are correspondingly equal. That means that the third angle must also equal. And in this case, it's pretty easy to see because what I have is the first triangle has angle B in it, and the second triangle also has angle B in it. So, we're going to use similar triangles to find the length of AC, which I've called X. So, let's take a look. In triangle ABC and triangle, I want to name them in the same order, so I started at this angle. So the equal angle is here, DBE. I want to find the length of AC, so what I want to do is prove that these triangles are similar first. I have a number of similar angles, so I can say that angle A equals angle D. I can also say that angle B equals angle B in both of them. And this is enough. I'm done. Because if I've got two, then necessarily the third one must equal. And so what I say is that we can say, therefore, we know that triangle ABC must be similar to triangle DBE by angle similarity. So I've just proved that the triangles are similar. Once I've proved that the triangles are similar, I can set up my ratios, my side length ratios. So I know that the side length AB divided by DB must equal BC over top of BE must equal AC over top of DE. Now AB is going to be 12 plus 48. So that's going to be 60. DB is only 48. BC, I don't know. BE, I don't know. and it really doesn't matter that I don't know. I'm going to be working with these ones instead. AC is going to be my x, and DE is going to be 36. So this is looking nice and tidy. So what I can do now is cross multiply. And we find out that x, which is AC, is going to equal 45. So AC is 45 centimeters long. So that's going to be 45. Okay. Now the trick here, and you want to make sure that you remember that, is that this whole length is actually 12 plus 48. So that's actually going to be 60 centimeters. And that you had to sort of watch and see what was coming up. I'll stop the video now and I'll do example 4 with you.